2013 exam papers, you need to rewrite this irrational number into a form of a plus b square root of 5, where a and b are rational numbers. So basically you're going to multiply by the conjugate, you expand normally, and then you will end up with this answer. So it's an achieved question. Now the next question is the next question is you've got u minus v. You've been giving the u the arcane diagram. So u is -2 plus 3i, and v is +2 minus I. And you minus the two numbers together, and your answer is -4 plus 4i, and you just plot that one back in the coordinates. So it's -4 real, +4i, and that's where the arc is. Okay, question 3. You've got one root of the equation is z3 of this is the equation, and the one root is 2 minus 3i. Because of the main equation has no complex components. Okay, so the main equation has no complex component. That's why we know that the next root will be, the second root will be the conjugate of the first root that's been given. So we've been giving this first root, so the conjugate of that will be the second root, and that's due looking at the equation has no complex number components, which is I. Then we assume that the third root will be a. Then we rewrite it as factors. When you rewrite the root as factors, obviously the signs will be different, so that will be -2 minus 3i, and that will be also minus, but this is 2 plus 3i, and here will be +a. And why would you be chosen +a? Because your answer is +b, and then you've got negative times negative, that's positive, so the third one must be positive. You expand normally. When you expand, you will got some terms to simplify, then you will end up with this one here. I've expanded the two terms in here, and then you will end up with this, the expanding for those two terms times the third factor. Now if I expand even further, I will end up with this type of equation. Now when I reached this stage here, you get the z squares is a common factor, so those are the two coefficients. Then you've got z common factor, so that's the coefficient of z. Now if you go back to the main equation, you will see there is no z square term, so that's why a minus 4 is equal to 0, so a is 4. Now if you know a is 4, so to find out p, you will come into this one here, is 13a, so you do 13 times 4 is 52. Now this is the first part of the question, was finding the value. The second part of the question is finding the other two roots, and the other two roots are the 2 plus 3i, so is the conjugate, and then the other one is a, which we found the value of a is 4. So a minus 4, so the value of a is 4, so the root will be -4. Okay. The next question here, so that must be negative. Okay, so the next questions here, you've got this complex number, and you want to find this equation. So you're going to substitute instead of z 1 plus I, and then because we have complex in the denominator, so we must multiply by the conjugate. Once you multiply by the conjugate, you will expand normally, simplify, and you will end up with this equation here. Now they want the args w, so the args they want the theta. Now the theta, you will find it using the tan inverse, so it's b over a, and then you work it out, and that tan inverse for 1 give you 45 degrees. Try to always use the tan inverse, as sometimes the cosine is different than the sine, and you will get both, it will give you different angles, so try to use the tan all the time. Now we're still in question 1 and we're doing E now. So E, you've got two complex numbers and you want to find the you need to find the value of K in here, giving that the args or the angle, if you multiply the two complex numbers, is pi over 4. Now because I've got this multiplication of complex numbers, I know that I need to multiply those two now. So you multiply those two complex numbers, normally expand, simplify. Now if the args of this is pi over 4 or 45 degrees if you'd like 2 degrees, it means that the cosine theta is equal to the sine theta, because that's how you get a 45 degrees angle, the sine equal the cosine value. That means the imaginary part is equal to the real part. Now when I multiply them, I have those are the real part, this is the imaginary part. So if I rewrite it as an equation, that's the real part, that's imaginary. If they are equal, rearrange it. I've got a quadratic now, factorize, I've got two solutions. Now because I've got two solutions, I need to see which solution is the appropriate one to the equation. Satisfy the other condition when the argument for u times v is equal pi over 4. Okay, so I've got negative 12 and I've got 2, so I took the k equal 12 first. I've rewritten it using the u and v complex numbers, using the k value. I've multiplied them using the calculator. So if you go to the calculator, you just go to menu, option, and go to complex to get the I, and then you can multiply them. You get the answers in here. You can also find the argument for this answer by going to the graphic calculator, menu, option, and go to the complex, and then you press argument, and between the two brackets you're going to write the complex number. Now when you press the argument, the answer is giving me negative 135. It's not 45, so I need to have it as 45 degrees, not negative 135. So that's why I know that the k equal negative 12 solution is not acceptable. Now I'll try the k equal 2, should work. So if you try the k is equal to, if you multiply them, you get 20 plus 20i, and if you try the argument in the calculator, you get 45. That's why k over 2 is the required solution. Alright. Now question 2. Now what is the remainder when this is the equation is divisible by x plus 2? Now because you've mentioned they would like the remainder and they give you an equation as divisible by another equation expression, that's when I'll need to use the remainder theorem. The remainder theorem, you take x plus 2 equals 0, this means x is negative 2. So if you substitute negative 2 in the equation, you'll get the value of the remainder, and that's how I got negative 7. Now the next questions is you've got two complex numbers in the polar format and you want to find u over v, and we know when it's in the polar format you divide the r values and you minus the you minus the thetas, and that will be the answer. So all of these are achieved questions. You've got the C, find the equation whose root are 3 times this. Now you're assuming the roots for this equation is a and b. So when it's quadratic, remember we look for two numbers, multiply them together give you negative 12, add them together give you 9. So that's why we a plus b equal negative 9. We're talking about roots, not factors. That's why I said negative 9. And then so that means 3 times, 3 times a plus 3 times b should give me negative 27, because 3 times 9 is negative 27. Now a and b should give me negative 12, so that means 3a times 3b give me negative 108, because 3 times 3 is 9, so 9 times 12 is 108. So it means that's the equation for that satisfies this condition here is x squared plus 27 minus 108. Alright. Next question here. I've got a complex number and then an equation where I substitute that complex number. And now I need to prove that if I substitute in this equation the conjugate of that complex number, the answer should be 0. Now I will substitute the conjugate number in this equation here. So I've substituted instead of u x plus y y, and then I expanded normally, and that's what you get when you're expanding. Now because I've got this equation equals 0, the only way you can get a complex number equals 0 when the real part is equal to 0 and the imaginary part is equal to 0. Imagine 0 plus 0 I is equal to 0. So that's why I'm going, after the expanding, I'm dividing it into the real part and making it equal to 0, and then the imaginary part equal to 0. Now I'm going to take the proof. So I'm going to take the same equation, but this time I'm going to substitute the conjugate of u. So I'm substituting the conjugate of u, expanding exactly the same what I've done before. I'm splitting them into complex number, the real part and imaginary part. So you're writing them as a complex number. Now we've already proven this format, or this real part is equal to 0. Now we've got this real part here. Originally it has negative, so if you take the negative out as a common factor, you will end up with positive, so it will be similar to what I've proven is 0. So that means this is 0, this is 0, 0 minus 0 is 0, and that's I've proven the requirement. Now, next question. Alright, so the next question is A, describe fully the locus points representing Z. So that's Z. I don't know why it's not showing properly. Here. So if z plus 2i and z minus 2i is purely imaginary. When it says purely imaginary, I mean the real component after you've expanded everything in here, it's equal to 0. Now, so remember we're talking about locus, so that's mean you're going to substitute instead of z the general complex number, which is x plus yi, and then you will, put the real parts and the imaginary parts together, and because I've got a complex number in the denominator, then I will multiply by the conjugate of the denominator. You need to make sure that you multiply by the conjugate of the denominator, not the conjugate of this part here. Okay, so you could make a mistake. So this is the plus becomes the minus, this stays, this term stays. Then you expand normally. After you expand, you simplify, and you will end up with this one here. Now, because we said it's purely imaginary, that means the real part in here is equal to 0. Now, the real part is x squared minus 4a plus y squared over the denominator is equal to 0. So if you cross multiply, and that gives you this one here is equal to 0. If you solve, you get a circle. Now, this is an equation of a circle with center 0, 0, radius 2. So remember the square root of 2. Now so the locus is a circle, but I'll have to exclude the point 0, 2, because if I substitute 0, 2 in the denominator here, I get the value of 0, and division by 0 is undefined in maths. That's why you will have to exclude that point. So imagine 0 plus 2 minus 2 is 0, 0 squared is 0, so 0 plus 0 is 0. So that's why it will give me undefined value, and that's why I'll have to exclude it from my circle. When you describe it, you don't have to draw it, but you must say the center and the radius, and if there is any point to be excluded. And that's an excellent question. Okay, now question 3. So again, we're starting with simple questions, which is achieved. Basically, you've got an equation, you just need to solve it and leave it in this format. So you definitely need to use the quadratic formula. Just substituting the quadratic formula, I got negative square root of negative 44. So I know that I need to use I, but the question say you can leave it as it is here, because you can't leave it, sorry, because you need to simplify this further. The 44 needs to be 4 times 11, because I can get the 4 out of the square root, and that's what I end up with. And then I simplify 2, 2, 6, 3, and that's why my final answer is negative 3 plus or minus square root of 11i. Now the b, again, you've been given two complex numbers, and you need to find p times conjugate of q. Just multiply them together and you get the answer. So it's quite straightforward. Now the next one, it says solve this equation in terms of p. Now when in terms of p, you will have to square both sides, because I've got a square root and the x is inside that square root, so I can't do anything. So I'll square both sides. When you square both sides, you will end up with this equation here. You eliminate the x's on both sides. You will end up with this one. You will divide by -6, and now I want to get rid of this square root of x, so I will square again, and that's where I will get the result from. So remember, when you have square roots, you will need to remember that you need to square. Alright, so number 9, find the solutions. Z to the power of 3 plus n equals 0 when n is a positive real number. Now you will have to rearrange it so that becomes z to the power of 3 equal -n. Because it's -n, means the r is in value, and that's why we'll write it in here. And the real part, or the real component of the polar form of the z to the power of 3 is -1. The real component, remember, it's cosine, so that's why I have to do cosine inverse to -1, and it's giving me 180, so the theta is 180. When we do root, remember, we do the theta plus 360k over 3. You can get these values here by using a graphic calculator, so you can go to the graphic calculator, go table, and then you write the equation, which is 180 plus 360x over 3, and you need to set your values maybe from -3 to 3, because you want to cover both negative and positive values. And then you will press EXE, and that's when you get the values. You only get to choose the values between -180 and 180 only. Alright, now here you've got E, you need to find the value of K, which makes this equation has no real roots. When they mention no real roots, straight away you will think of b squared minus 4ac less than 0. Now you can see I don't have any quadratic, so that's mean I need to do something. And because I want to find the value of k, and the k is inside the square root, so I need to square. But I can't square straight away. You need to have the square root term on one side of the equation. So I rearranged, got that one here. I square both sides, got into this stage, expand, rearrange, make it equal to 0. I'll end up with this. And because when I've got this part here, this is my quadratic, then I will apply the rule. So b squared minus 4ac, I got this, less than 0. I rearrange, solve the inequality, and that's why I get k less than -18 as my answer. And that's it for 2013. Thank you and good luck.